We're doing a warm-up on adding, subtracting rational expressions. So we are starting with addition and subtraction in this first problem. First thing I'm going to do is push that sign so I don't lose it. But I need a common denominator. And what do you notice about this already? I have a common denominator. So I'm going to keep my common denominator of x squared minus 1. I didn't even need to factor it and find pieces. I'm just bringing it over. And then I'm going to add my like terms for this whole numerator. So I get 6x plus 6. Now look at your paper. A lot of people left it right here. Once you add and once you get your common denominator and you put all the pieces together, you're supposed to factor. So 6 comes out of the top and I'm left with x plus 1. And I do feel that we're forgetting our most basic GCFs. Like we just ignore that. This is a difference of squares. X plus 1, x minus 1. So this does cancel. What's your final simplified answer here? 6 over x minus 1. Domain restrictions are fair game on these problems. What can't x equal? We're going back to that original denominator, which was the same throughout, which is right here. Well, it can't be minus 1 or plus 1, but x could be 0, because if I put 0 in here, I would still get out negative 1. So it's only coming from the denominator, okay? So it's just plus and minus 1. It can't be negative 1, and it can't be positive 1 here. Okay, now if you look at this next problem, if I just jump in, I'd be giving this the x squared plus x minus 12 and the x plus 4, and it gets way too big. Before I do anything, I'm going to adjust this, and I'm going to see what this factors to. If you think about this, this factors to be x plus 4 and x minus 3. And that's really convenient because now what do you notice? Yeah, so this already has the x plus 4, so it only needs the what? X minus 3, top and bottom. And this already has the x minus 3, but it does need the x plus 4, top and bottom. Now, you can do how you want here and what works for you. I'm going to write the common denominator once. X plus 4, x minus 3. I have 3 pieces in my numerator, so I could do the work above. I've been doing that a lot recently, or I could just bring it down. I'm going to distribute and have x squared plus 4x. I'm going to distribute and have negative 3x plus 9, and I have my plus 7. So there are the 3 chunks. That's why I put that big plus sign in there. Okay, I end up with x squared. 4x minus 3x is just 1x, or x. 9 and 7 is 16. Now, before I go any further and I bring my denominator over, does this factor? That's why I kept this factor. Are there factors of 16 that add up to 1? No, we're not going to find anything that factors. If it factored, I would factor and cancel. Since it doesn't, I'm going to put this back together. Now, you could FOIL this, but didn't this exact denominator come from the x squared plus x minus 12? So nothing changed on that. That's why I can go back to it. Domain restrictions, what can't x be? Original denominators were these pieces right here. These were your originals. So right here, x can't be negative 4 or 3. Well, Delta Math would accept, if you wouldn't put this in, but like you could put in your numerator and your factor denominator. A lot of textbook answers keep the pieces. I unfactor it because I'm sort of pushing you guys to practice distributing and foiling. So I do expect, like on graded assignments, homeworks, quizzes, tests, that you'll put it back together. The factoring was to see if anything canceled, then we put the pieces back. Okay, last problem, easy part, change the sign. Now here's the deal. I got A's and B's here. There's nothing canceling because there's not an A here. So I'm stuck with this. This does factor. This is a difference of squares. At this point in our math, we should be able to see it. It's 2a and 2a. And what's going to give me a negative b squared? 1 positive b and 1 negative b. Instead of being a number, it's a variable. Okay, how does that help me? Well, it does, because this already has a 2a minus b, but it needs the 2a plus b, top and bottom. And I'm just sort of putting it up here and off to the side so I see it. This has the 2a plus b. it needs a to a minus b. 2a minus b. Okay, here it comes, common denominator, 2a plus b, 2a minus b. When I go to clean up my numerator, here are the three chunks. Over here, I'm distributing a 3a. Okay, so for this last problem, I went ahead and I did a pre-distribution here because we were trying to finish up. So I distributed this piece. I came down here. I distributed the middle. Here it is. And then the last piece is here. Okay, now I'm going to clean up my pieces. So I have a 6a squared. I have a 3ab and a 2ab, which is 5ab. And then I have a negative 2a squared and a 2b squared. Oh, so I missed that. 6a squared and negative 2, this should be a 4. So let me fix that. All right, so there it is. The 2a squared, or 6a squared and negative 2a squared is 4a squared. Here are my like terms here. And last is this plus 2b squared. All right, I'm keeping my denominator factored for good reason. I should always check and see if my numerator factors. So it does. It's going to factor to be a 2a. I think I still screwed something up. This should be a 4. Okay, so I found a mistake here. The negative 2 times 2 should have been a negative 4 because this wasn't going to factor. So this up here should have been a 2. A little bit of chaos today. All right, now when I go to factor, it's 2a times a, and then when I put this in here, I have a plus 1b and a plus 2b. And the reason I chose to do it that way is I knew I couldn't pair up the 2's. So here it is, 2 times 2 is your 4 with ab, 1ab, there's your 5ab. So the factoring helps because the 2a plus b cancels with the 2a plus b, and this was gone. So all I'm left with here is a plus 2b all over 2a minus b. And some of my b's look like 6's. I'm not going to ask for domain restrictions here, and it's because of the idea that at this point, if a is 1, b can't be negative 2. If a is 2, b can't be negative 4. So you would have to actually come up with the general rule of what these can't equal, like b can't equal negative 2 of a. So you could be here for a while defining your domain restrictions unless you defined a general rule for your a and b.